So in this video, we'll be examining how to find the domain of a function, and we have about six different functions that we'll be finding their domain. We have rational function, and also let's dive in quickly to how to find the domain of a function. Now, whenever you have the domain, whenever you have the function, a linear function such as 2x minus 7, or a polynomial function such as x squared plus 3x minus 5, or another polynomial function such as 2x cubed minus 5x cubed plus 77x minus 3, all of these are polynomials. So any polynomials in the world, their domain ranges between minus infinity to positive infinity. So you should have that at the back of your mind. Whenever you see a polynomial function or a linear function, the domain of such function always ranges between minus infinity to positive infinity. So let's check for other types of function and how to find their domain. Now, when you look at this example, this is a rational function. Rational functions usually have a numerator and a denominator. But when it comes to finding the domain of the function, our primary focus, our main focus is always on the denominator. So once you check this question, you notice that the denominator of this function is x minus 2, and you are going to check for every value of x that will make this function become infinity. Now if you check for 1, you have 5 divided by 1 minus 2, that's 5 over minus 1. When you check for 2, you have 5 over 2 minus 2. 2 minus 2 is 0, so you have 5 over 0. 5 over 0 is infinity. Do you get it now? So it simply means that the function does not exist when s is equals to 2. Do you get it? So what you are going to do is that you are going to equate x minus 2 not equals to 0, such that you can have the value of x to be equals to 2. So the value of s can be any other thing apart from 2. Do you get it now? The value of x can be any other thing apart from 2. So when you put the value of x to be 3, it will still give you a valid answer. But immediately you insert 2, you have infinity. Alright, so just like every other function, every other rational function, we have x squared minus 9x plus 20 as the denominator of this function. So we want to write out the domain of this function. Now you notice that for every value of x, this is a rational function, and the denominator is a polynomial function. Do you get it now? So just like the previous approach, we equate it not equals to 0 such that we'll get the value of x. And since it is a quadratic equation, you are expected to have two different answers. And for a quadratic equation, our focus is always on the constant, and the constant in this question is 20. So you look for two numbers such that when you multiply them together, you are going to get the constant, and when you add them together, you are going to get the term that has x. So by doing this, we are able to arrive at minus 4 and minus 5. So it simply means that s cannot be equals to 4 and s cannot be equals to 5 when we collect like terms. S cannot be equals to 4 and s cannot be equals to 5. So it simply means that s can be any other thing as long as real number system is concerned, but it can never be 4 and it can also never be 5. Alright, so let's check the number line representation and the interval notation of the last question. So don't forget x can be equals to 4 and s cannot be equals to 5. So you draw a number line and you indicate 2 points at the center where you have 4 and where you have 5. Do you get it now? And you draw a line to your left and to your right and indicate negative infinity and positive infinity respectively. So it simply means that the value of s can be 4. It can be, it can be any other thing apart from 4 and 5. And in interval notation, you have minus infinity to 4, union 4 comma 5, union 5 comma 8. All right, so this is a function, this is a radical. So we have it we have the square root of x minus 4. We are asked to find the domain. Now you have to take note that you cannot have a negative number in enclosed in a square root, right? So the value of x can have every other number apart from numbers that are greater than 0. Do you get it now? So we say that x minus 4 greater than equals to what? 0. If you put x to be equals to 4, you have 4 minus 4, and that's square root of 0. Do you get it now? So we have that all of the values of x that you must have to have positive answers of the function must be greater than equals to 4. Is either it is equals to 4 or it is greater than 4. So in representing this on a number line, as usual, you draw your straight line and you put that very number on the center line and draw it to the right hand side. So it means that every number, all the values of x must be 4, must be 5, must be 6, must be 7, must be 8, up to positive infinity. So we are not considering negative values in this. And when you are representing this in interval notation, you must take note of the brackets that you are using to enclose the domain. So the bracket must be a closed bracket. So you have closed bracket 4 comma infinity. So that is the domain of this very function. All right, so similarly, we have the function of this square root of x squared plus 3x minus 28. So we do the same thing as usual since it is enclosed in a square bracket. So in a square root, then we take the greater than equals to 0 of the function, and by solving for the value of x, since the function is a quadratic function, we have the value of x to be 4 and negative 7. So this simply means that the value of x can be any other values between negative infinity to positive infinity, but there is an exception. So we have two different exceptions. The exception is that the value of x must be less than equals to negative 7 and it must be greater than equals to 4. Did you get it down? So the negative value there is indicative of the fact that the value of x must not be negative, so it is closed. And the positive value means that it is also closed, which must also be greater than equals to 4. So the interval notation, you can see you use a number line representation. You indicate the negative number to the left and the positive number to the right, and you close the number line. And similarly, you must not also forget to add a close bracket when indicating your interval in interval representation of the domain.